Hi, my name is Andrew Livingston. I'm the lecturer from the BIM module, or BSV11159. This is only a short video, predominantly those who are studying at home. And we'll be looking at this naming format. We discussed it last week in the last week's video, but we're going to take it a little bit further today. In the class this week, the students in the class started to develop this naming format and want to try and deliver that to the rest of the class just now. So I'll change screen. So before we get into the naming format, what we'll be doing today, you need to have already downloaded and started to use the platform that you'll be drawing your retrofit project in. You've got a choice of whatever platform you want to use, Revit, SketchUp, or anything else you happen to have. If you are using Revit, make sure that you understand how to put in the names for components and you've not just used Revit for 5 seconds in the past. If you are relatively new to 3D modeling, we're going to suggest SketchUp because it's very quick to learn. And if you are new, you should have already had a look at these useful links. Please review before the 4th of February. And what that link there takes you to a playlist of short videos hosted by myself. And it's not about necessarily drawing in SketchUp, it's about using BIM as an introduction within SketchUp. The protocol that are used in these videos is a very simplified protocol. We in the class will be developing our own, a little bit more sophisticated than one used here, but the principles are exactly the same. Each video is roughly 10 minutes in length, and there's 18 all in. You will need to have done all 18 videos to understand what you'll need to do for this module. So that's the useful links. We've also got the retrofit project files. Obviously, last week we looked at Saphira, and this is for the building performance. I think some of you have already been watching those videos. And these are the files for it. The additional information and the 3D model for the Saphira template, and then a building performance input data as the existing building. Okay, so that's all that. For the actual retrofit project, though, for the BIM model, the starting model to start with, we've got it in various formats: SketchUp, Revit, DWG, and of course IFC, firm favourite. We've discussed that a few times now. We also have this BIM protocol. We'll jump straight into that in a second or two. But before we jump into that, a bit of light background reading. There's a Building Information Modeling, or BIM protocol document by CIC. That's a good reading first if you've not already read through it. So anyway, let's go straight into this link, which it takes you to here. There's a spreadsheet, and this is the external database that we in the class will be using, and we'll have to tie that into our BIM model, and it is a workflow. How does this actually work? So obviously it's only just been started, and you've essentially got a location, a level, a type, a material, manufacturer or subtype, and a differentiator. So how that would be a location. For example, we've got substructure, superstructure. This will be developed further by the students in the class, but predominantly you will be looking at the insulation layer. Perhaps the windows will be maybe level 4, or maybe you've got external insulation. So we'll have to add these up. If there are data sets used in here, please don't modify existing ones, only add new ones to it, and try and make sure that you don't have duplicates within here. Normally in a large firm, you'd have a person responsible for this entire database, plus much more, and you wouldn't be allowed to just add in manually. It'd have to be approved before it's accepted. But within this class, we will be assuming that everyone's playing the same rules, and don't mess up somebody else's one. Add new ones in, but if one already exists for internal installation location, don't create a second one. Right, we'll come back to that in a minute or two. Let's go to our actual house. Here we are. There's the house, something like that. I've already started modeling, to be fair. So what we'll do is we're going to do a very simple example of, because in this project you will be wanting to retrofit. You're not changing the layout, you're not changing the design of the house or the use of the house. You're just changing the building performance retrofit, i.e. better U values, better thermal insulation I mean, and air tightness. So things like insulating the walls, the floor, the roof, either internally or externally, changing the windows, and you'll come up with a scheme that you're going to propose, and you'll have a justification for why you're doing that. Um, this module is more about the BIM data though, so don't get caught up too much on trying to use exotic corks from Portugal, or trying to use very interesting wood fiber insulations from a very bizarre manufacturer. Just get a system that works, but in line with the project brief. So please read that project brief again. Now it's in line with the timber and construction roadmap. So let's do a section. I'll move this section into, say, the back bathroom, and I'll just demonstrate on one wall only. I'll demonstrate in this wall, and for simplicity, I'm going to hide this just now. So then, and I'll change my colouring. Right. You see, I've already started to put together a framework. I'm going to select that stud, and I'm going to look at the component name for that. We've given that a name, 3 underscore O or 0F underscore stud underscore timber underscore C16 underscore 001. What does that mean again? Let's have a quick peek at this. Make it a bit smaller so we can see what we're doing. So the location, number 3, that's an internal insulation. That just means that it's in that location. It's internal, it's an insulating layer. It's not a superstructure or substructure, so it's not a structural frame. It's just a frame just to hold that insulation. The level, well, it's actually first floor, so that would be 0F. And it's a stud. STUD, it's a timber, or it doesn't say timber, it's just a stud. That could be metal, timber, doesn't matter. Now the material, TIM, that's timber. And then after that, manufacturer or subtype, we put in there C16, and that happens to be a strength class of timber. I wouldn't overly worry by that. I would imagine that any timber that you'll be doing in this project will all be just C16, basic simple structural timber. So don't get overly worried by that. So C16, and the differentiator, 1, 2, 3, 4, so forth. Now, what you'll find, I'll put this aside just now, move my cat out of the way for a second. Come on, cat. Sorry about that. Sorry, Oscar. Right, back to the class now. So we can see this stud here is number 1, but so is that. It's the same product family or family component or dynamic component in SketchUp it's called. It's the same component, just another instance of it. For this one here, it's actually a smaller stud, and that, as you can see, is 003, and this would be 002, the bottom one, and that would be 111. Okay, the rails, Now normally I would call this a bottom rail, and I would call that a top rail. Then I would have a lintel and a sill. Well, we're just going to call these all rails, just for simplicity, because we're not structural engineers, we're architectural technologists or facility managers. So we've got a rail, that would be number one. That top rail would also be just called a rail, number one. And then this lintel and the sill, well, they're just rails number two, made out of C16. I've happened to make that 95mm by 45mm, but you could make that slightly thinner. You couldn't make it any thinner than 38mm, but for just now, 45 is fine. And I put insulation in there. With the insulate it was something. Now, I've shown something that I'd expect none of you would do, because this would not follow the brief that I've given. The brief that I've given is to follow the timber and construction roadmap. This is actually EPS insulation, so you can see 3. So 3 is the insulation layer, 0F is first floor, INS, what does the INS stand for? INS is insulation, and then EPS, insulation expanded polystyrene, and then the manufacturer ecosystems. Well, in actual fact, they do not manufacture such a thing. They would be more likely to manufacture things like wood fiber insulation, but you can come to that later on. And then it would be a differentiator 002, 001, or as the sizes need to be. So these all have names. So I'll just finish this off. I'll just move that across, keep the original, and I think I may actually have one here just to save time. It's all about saving time now. There we are. Let's double check I've got that correct. Yep, 1. That's another instance of the same one, it's the same dimension. 2, 2, 3, and that'll be 4. Absolutely fine. So there's our insulation. Now I'm going to put on a plasterboard on there in some way, shape or form. For the facility managers, I'm not overly worried about how you put the plasterboard on. Normally I would expect it to come in sheets of sizes of 1.2 meters by 2.4 meters. However, just because we just do move on with this a little bit, we'll just draw the sheet all as one. Now, if you are an architectural technologist and you're on this module and you're in class, or doesn't matter in class or not, if you're an architectural technologist, I would expect you to draw this in a slightly different way. So I'll do that for you just now, just to show. So for the FMs, I would expect it to be like that. And that product there, I'll select the product, it's got a code of 03 OF, first floor, INLIN, internal lining. PB is plasterboard. I'll just bring this over. PB is plasterboard 15mm, and the manufacturer, British Gypsum. So if you are one of our architectural technologists, what I would expect you to do is something like this. I'll do it from scratch. 2 meters 400, and then I would expect this to be 1 meter 200. Oops. And then the thickness of that, we'll just stick with the 15 mil. We'll right click, make component, and we'll use that naming structure we had before. I'm going to cheat. I'm going to go in here. I'm going to take that name. I'll go here and right click, make component. I'll paste that name in, but I'll call it 2 to be different. This is what the architectural technologies would be expected to do. They would then place this board here, and then they would place another board to the side of it. What we'll do is we'll do this. Keep that there just now. We'll right click, make unique, and then we'll cut a hole in this one. And then we'll just put this. Now, what in reality though I would be looking for, again this is more for the architectural technologists, this would be wanting to come along there, and if I just hide a few things, I'm going from the back, and I'll snap it on. As long as that distance is not greater than 600 mil, then we're fine. Let's make that unique. Same up here, make that unique. Actually, we'll come back to that one in just a second. And we'll put another sheet of plasterboard on. Keep the original where it was. Make it unique. Select it. Put it in. Now the reason why we've cut the plasterboard like that is to go around the window. However, you can see that we've got a stud here, and we've got another stud here to catch the edge of the plasterboard. We still have a problem. Our plasterboard's too short for this particular room. So in reality, what you would probably do in real life is put an offcut at the top here. keep the original, sorry. Make that unique. We'll just pull that down very, very fast. So normally speaking, this is what you would actually do. You can indeed well, first of all, there's no support here, which would be incorrect. You'd have to put a support in there. That would normally be what's called a noggin or a dwang, depending upon whereabout in the country you live. Or a bracing piece, sorry, is another way of saying the same thing. And it would look something like that. But you'd want to do that all the way along. So this here would have to come down as well. And so with this one. But again, this is really only for the FMs if you're happy to do this, just to make it a bit more factually correct. I'd be very happy if you'd done that. But I'd expect the ATs would do this. Make this unique. Again, all these things that I'm doing just now were all covered in my tutorial videos. I'm sure by now you're already moving on very fast with that. So we'll just very quickly just finish this off, may as well. For all it's going to take. Make unique. Go in there. Just pull it. This is very different to what you would normally do as an AT, but we're looking at it more as for manufacturer, or what we would call RIBA Program of Works, Stage 4. The drawings go to somebody who then intends to manufacture the panels in a factory for you. They're not just cobbled together on site randomly. Make unique. Now there are processes you can do to speed this up. We're not going to be using any of those add-ons tools. We're just trying to do it first principles ourselves so we fully understand what's happening behind the scenes of these dynamic design tools that we have access to. Things like Revit or Grasshopper, Rhino, that sort of thing. Almost there. So you can see that it's a little bit detail orientated, isn't it? But that's the whole point. When you're doing a building for manufacture, this is the sort of level of detail that's required. And of course, the last piece of plasterboard. Again, we'll make that unique. We'll go in there and we'll pull that there. Right, now what we want to do is just check that we've got everything named correctly. We'll call that number 3 for just now. We'll call this number 4. We'll call this number 5. We'll call this one number 6. Just so they've all got a unique name. And it's the same with the insulation. That's number 3, 3, 1, 1, 2. Yep. So this is going to give these all a unique name, 1, 2, 3, 4, if they're unique. And I'll put the building back together now. So there we are. We've now got that bathroom with just one of the walls insulated. It's a timber frame wall, lightweight timber frame wall with insulation in there. So that's the level of work that we need to do. If I just go back to that spreadsheet, what are we expecting you to do? We're expecting you to go into this spreadsheet and add components into it. So we could add in, I'll not do this, I'll leave this for someone else. You could go in there for, and you could go external external insulation, so forth. If you do that, or other layers, you have to put your initials against the data you've put in. I'd imagine there might be a few more locations be added in, because internal insulation, not everyone will be doing internal. Some people may choose to do external insulation on the building, could be a good option. And how would you do that as a wood fibre timber and construction roadmap approach? You absolutely can use wood fibre insulation on the external. You have a look online for the various products that would do that, or do internal as I was showing you there. There's positives and negatives to doing the insulation external and internal. Pick one, go with it. Get the U values for the walls, floors, roof, ceiling, walls, floor, roof, windows, and the air permeability. Think about the air permeability. We went through that last week. I don't need to go through it again. So if you add in any points within this, please put your initials in. I think I've got everyone's name in the class. All the initials are no doublers, I don't believe. So I want to see every student to at least have several components in here that they've added in. Now, let's go back to that model for a second. Let's delete all of that. The next time we do this video, what we'll do, or the next video that I'll do, what I'll do is I'll show you how to extract that data from the model. and pull it into what's called a comma delimited file or a CSV file. Normally you bring that into something like Airtable or Power BI by Microsoft, and you would process the data there. We won't be using such platforms. It's another tool to learn. So what we'll be using Microsoft Excel, but we'll be creating macros to pull the data, to do the exact same thing that these other platforms do with this BIM data. And from that, we'll be creating takeoff tables, quantities essentially. We'll be pulling in costing. So we've not done any costings yet. We'll be doing that in again one of next week's videos as well. So for just now though, keep on going through these videos, try to make sure you're up to speed with it, and then start thinking about how are you going to insulate the building, what are you going to do to this building to bring it up to a level. Please double read the brief set out on this project, and yes, it should all be quite good fun. Any problems at all, my email address is on the middle page. It's a.livingstone with an e at napier.ac.uk, or arrange for a Teams call if need be. That would be amazing. In addition to that, I'm going to send out an email to all of the FM students requesting for a live session, probably 5 o'clock on Monday. If you can't make it, don't worry, we'll record the live session and I'll post that online. And we'll try and have these live sessions on a fairly regular basis from now on for the FMs, facility management learners. Right, for this video, thank you very much, and I'll speak to you soon.